Welcome everybody to a brand new week of Computer Science 40. This week we're going to be moving to some software engineering topics. Software engineering is the computer science-like discipline. A lot of times the computer science program and software engineering program are considered interchangeable, kind of. But they're really a little bit different, at least. They're both learning to program, I guess. But computer science has a lot of like math and proofs and like finite state machines and like theory of computation, algorithms and things like that in it. Software engineering is project management. I mean, it's programming also, but also like things like program management. How do you communicate with people? What tools do you use when you code? There's obviously a lot of overlap. I mean, every computer science major is going to use like GitHub or Git at least these days. But you can think of software engineering as like the question of like, how do you get good software written quickly, on time, and on budget in a group, right? And that's a hard problem. It really is. Software is one of the few disciplines that just fails at its tasks like all the time, and it's considered kind of normal for you to just be like, yeah, we tried and we failed, but pay us anyway. Like I don't know any other discipline that would be like, oh well, we tried building a bridge, but you don't have a bridge, so yes. A for effort, exactly. In computer science, we believe in A for efforts. Okay, so software engineering is the study of like how you can go about organizing a team, or like what, setting up Vim even might fall under software engineering. Do you guys understand? Like, how do you organize a group project? How do you schedule which order you do tasks in? Like this would all fall under software engineering, and you can actually get a degree in software engineering. Discord, yeah. Slack, it's also very common. Okay, so we're going to talk today about the software development lifecycle. We're going to talk about Agile. We'll talk about test-driven development. We might get to the other ones as well. I do want to give you some lab time where you can actually implement TDD, test-driven development, as we didn't do lab time on Friday. Your lab time will be today. You're going to do FizzBuzz, but in a different way. Instead of doing it the normal way, you're going to do it the TDD way, the test-driven development way. You'll have an hour to do that. Okay. So the software development lifecycle is sort of the traditional way that software is done. I don't want to say that because it was never actually exactly done this way. But like I worked at a military contractor, and this isn't, too far afield from how things would work. So let's say that you're given a year to implement some large software project. Like you're gonna implement a new time card system for New York. Like the city of New York has noticed that a lot of its employees are scamming on their check-ins. Right? It's like, you guys know how like a time card system works. Like you have like your ID card here, and then when you go into work, you punch in, you swipe your card. Now you're on shift. You're getting paid. And then at the end of your shift, swipe it through the time card machine. You're now clocked out. Seems pretty easy, right? Yeah? Like, you guys could probably write it. What do you think? If you could figure out a way of getting the current time, you could probably, write code to swipe in and swipe out. On a basic level, doesn't seem too bad. You basically subtract the ending time from the starting time, and that's how many, minutes you paid them for, if you're tracking per minute or per hour or whatever. BRB, my dog's getting into trash. It doesn't seem that bad, right? But the reason why New York wanted a new time card system is because people were fraudulently checking their friends in, right? So let's say that Olson was my friend, and he just didn't feel like coming into work today. So he could hand me his ID card, and then I swipe in my card, and then I swipe in his card, and he's now on shift. And then when I leave for the day, I'm like, look, I got one card. Nope, I got two. And I swipe him out as well. He just got paid 8 times whatever his hourly rate is. And yeah, he says thanks. He spent the day at the park, whatever, looking at the pigeons or something, right? And so rather than, I don't know, arresting their employees for widespread fraud, instead they said, okay, we need a software solution to this. And so let's add biometrics, right? So you go into work and you swipe your card and you put your thumb on a thumbprint scan, maybe do a retina scan, face whatever, a DNA test. No, probably not. Some sort of biometric marker, and so you swipe in and you do a biometric, and then it clocks you in. And then at the end of the day, you do the same thing to clock out. If you want to talk about complications, let's actually talk about this first. So let's do this requirements gathering and analysis. So that's the task. You guys are going to be you guys are my team. You're the people who are going to implement the new New York time card system. What sorts of things do you think the system needs to handle beyond the basic clock in and clock out? What kinds of things can go wrong? What do you guys think? Give my coworker my severed finger. Spit on the card, then swipe it. Yeah. Yeah. If you use saran wrap sometimes, like that'll actually give you the last fingerprint. Breaks. Yeah, clocking out for breaks. And then you have to like make sure that you don't dock them, unless the break is over the break limit. You know what I mean? Like, so you need to handle breaks. That's going to add a little bit of complication to it. There could be unrecognized cards or unrecognized biometric data. Yeah, then what do you do? Right? So an employee shows up, they put their thumb on it. It's like, we don't recognize it. You're like, but I work here. Sorry. What do you do? Retry? Yeah, I mean, you keep hitting it and it just doesn't work. Like sometimes scanners just don't work right, if you've ever been to a restroom and you've tried to wash your hands, and you're like doing this underneath the sink, and the thing's not turning on, and like it'd be really nice to have like a faucet sometimes, right? Clock in manually on a sheet of paper, maybe talk to an actual human option. Sure. So these are use cases, right? Like what could go wrong? What if somebody forgets to clock out? Then what do you do? Have you guys ever done this? Like when you're on shift, like you've used a time card system before and you clock in and you just leave, and you forget to clock out and like, oh, sweet, I'm about to get paid, 24 hours, Contact HR or supervisor. Yeah. See, so what does the system need to be able to do? So if you are writing the program that will handle this, what do you need? What do you need to implement? What has to be in the system? Wait for them to contact me. No, you're writing. You are making the time card system. So what sorts of features have to be in the system to handle that? Because these are the use cases, like the different things that can happen. People forget to clock in. People forget to clock out. People try the thumbprint scanner. It doesn't work, right? I haven't had a real job yet. Cheat code. You need to have a manager account, right? So you need to have not just the usual employees, but you have to have a manager who can, for one thing, approve the hours, because like they can look at the hours and be like, yeah, that looks about right, and thumbs up it. But also, like if a person like drives home, they're like, oh shoot, I forgot to log out. They can call their manager. The manager can log in and be like, all right, what time did you leave? 5:10. Okay, and they can do a manager override and fix the hours, right? And so the way that you're supposed to do it, using the SLDC or whatever it's called, software lifecycle development, whatever it's called, the traditional waterfall method, it's called. You spend 2 months, driving around to all the different hospitals in the area, talking to all the people that clock in, clock out, talking to the HR people, talking to the managers, trying to figure out all the different features you need. I need a manager override. And then the supervisors will say, we need a supervisor override over the managers in case they vanish, and then we can put more managers in, or hire and fire managers. And then, the person who owns the company needs to be able to hire and fire the supervisor. And so you have to have like different tiers of like access and things like that. And then all has to be done. Perm logs you out after 13 hours. Yeah. Built-in contact functionality where other authorized users can view your profile. Yeah, so you'd have to gather up all this information. Spend 2 months doing this. Or 2 years. It's entirely possible that you could just multiply all this by an order of magnitude. Like 2 years might be possible. Okay. And then you're going to spend 2 months generating what's called a spec. Okay. So after you've gotten your stories from all the different managers and supervisors and everybody, then you all meet and you cover the wall in like a giant conspiracy theory thing where you design all the different pieces of the puzzle. We need a database here, and we need a web interface here where the managers can log in, and then we need user accounts and different tiers of user accounts, and these people can access these people, but not these people. And you sketch out the entire thing. Yes, that's exactly what I was thinking of. Or maybe in like A Beautiful Mind, the Russell Crowe thing there as well. So, yeah, that's basically what these UML things look like. UML design for time card system. Let's see if we can find a picture of something like this. Yeah, these things like are not nearly complicated enough. But yeah, I mean, you're kind of getting the idea, I think. Like you just have, you have your actions and your responses and triggers, and like these things just end up just becoming massive, right? And then what you do is you generate what's called a spec. And the spec will have a hash map. Yeah, just hash maps over. And then what you do is you write like this 300-page document saying, this is what we're going to do. This is what the login is going to look like. These are the 4 different access levels. This is how you make an account. This is the function will output how many hours people have. This is the function that will verify people's things that they didn't, they weren't logged in twice, for example. Because you could log out, but forget to log out, right? You just misswipe it. You go home and then log in again. Now you're logged in twice. You're getting paid twice as much, And so everything has to be in this spec. You hand it to the client signs off on it, and that's a contract. Basically, it turns into a contract. Like if you do the things that are in this giant spec sheet, then your company gets paid $100 million. Cool. All right. And you show how all these things connect together. Then you implement the code in 3 months. And if that sounds unrealistic, it is, as it turns out. So you're not writing any code during these 2 phases, right? You're writing code here. And in reality, would they probably be writing code? But this is the software development lifecycle. It's not good. So you write the code in 3 months somehow. And for something simple like a time card system, you can probably do it. If you've got some off the shelf biometric, fingerprint scanners that come with software, I could probably hack something together in 3 months. Sure. Then you test it for 3 months, and you make sure all the different pieces connect to one another. So the biometric system is connected to the employee databases, and it's connected to the time cards, and the login stations all are synchronized, on the same time zone, and because it'd be really awkward if you clocked in on Pacific time and clocked out on Hawaii time. You'd lose 6 hours every day. You know what I mean? So you have to test each function. You do functional testing and integration testing where you connect functions together. You do end-to-end testing, and you sort of test at all the different levels. And then you finally roll it out to the client. So you go into the hospital, you install your new time card system, and then you wait for things to break. And people come in, beep, beep, thumbprint reader's not working. Is it our software? Is it the hardware? And, you have a person sitting there and pull out the sensor and maybe switch on another. No, it works now, I guess. Or maybe just the database just crashes from too many accesses at once. And then you go into what's called the maintenance cycle, or the debugging cycle, where basically now that it's out, they will usually hire you for a year or two to do maintenance releases on it. So when you find bugs in it, it pays for one of your software engineers to fix it. And occasionally, though, like something will come up that's like not really a bug. Just like, it'd be really nice if we could have facial recognition in addition to thumbprint recognition. That's not really a bug, right? That's more like, that would be a feature. And what do you do when the customer has enough feature requests? What do you do? What do you guys think? The client's like, I want you to add facial recognition. What do you tell the client? Start over again. Yeah. You go back to the beginning. So you do requirements analysis and you're like, okay, you want facial recognition. All right. Just from the front, from the sides, oh, we also want DNA testing. Oh, we also want, or you say no. Yeah. But you start over again. And then you eventually, it starts looking like a circle, right? You make your spec, you implement it, you test it, and then it goes into maintenance where you're debugging. But also, like, people will be like, yeah, it'd be really neat if we could add, different time cards for different kinds of people, so that not everybody has the same. Maybe we can add key fobs. I don't know. And then you make a spec saying we're going to add key fobs, we're going to add facial recognition, we're going to add DNA testing. It'll cost you $17 million, and then the process repeats. Okay. There's a more detailed version of it. Make market requirements, product review, requirements complete, architecture guidelines, prototyping, human factors, functional specs, architectural design, architectural review, design spec, unit testing, plan, design review, design complete. Coding only happens on step 14. Interface freeze, implementation, code inspection, unit tests, implementation freeze, QA. And you got a year, go, And the trouble with this is that oftentimes you don't know what you need. You don't know what you need until you need it. You're writing code. Like, I don't know what I'm going to name a variable until I use it, right? Like, if I'm writing some code that's going to like compute the score or something, I might call it like team 1 score or something like that. But then like later on, I realize that it's just like only used for like their field goal count or something like that. It's like when I actually go to actually use it, I'll be like team 1 field goal count. And it's like variable not found. And I'm like, oh, I can fix that. Then I go up to where I made the variable and I change the name to whatever it is. It's only when I use something that I actually know not only what it should be called, but really what it's going to be doing in a lot of cases. Or I just have the right name for it sometimes. And and the trouble with the waterfall model, where you design everything in advance, is that you think you can know the future, right? You think you know how the implementation is going to go. And a lot of times you don't. In software development, we get surprised all the time by like, oh, this wonderful design I have is actually terrible. It actually doesn't work the way that I thought it would. But here's the kicker. The spec is a contract, right? So if you don't follow the spec, you don't get paid. So what you do is you implement the bad spec and just have it like half work or something. You hand it to the client. There you go. And they're like, but this only half works. I'm like, well, it was in the contract, so pay me. And then they pay you. And that's the benefit of having a 300-page spec sheet that identifies everything you're going to do in advance, even though it's completely unrealistic and it never works. You get paid, right? That's a very strong advantage to doing the waterfall method, is that you get paid. We once delivered a military headset that was too heavy. It's like, it was like a VR headset, and it was too heavy. It like hurt people's necks, And so, they can complain about it. It's like, hey, we sent you we told you it was going to be 500 pounds and you signed off on it. So, you get to pay for their healthcare expenses as they shatter the vertebrae in their necks, not us, Whatever. If you want us to do it again, if you want us to make a lighter weight version of it, you can pay us. We'll go through the process again. We'll design you a new VR headset that is not 500 pounds. And we will, in the meantime, attach a rope to the ceiling and just have it like a bungee cord holding the VR headset up, and it'll take some pressure off their neck. There you go. And you think I'm joking. Well, I am. It wasn't 500 pounds. 500-pound noose VR. It wasn't 500. It was like 20 or something. That's still a lot of weight to have on your head. So, all right. So the downside is this system does not work very well. You usually don't know what the future is going to hold for you. Sometimes you do. Like if you were doing Madden 2024, you probably could get away with this. You know what I mean? Because like it's a familiar territory. What are you changing honestly between Madden 2023 and Madden 2024? Probably not a lot. You know what I mean? Like I don't even know. Like, does anyone know what is new in Madden 2024? Field sense and sapient technology. All right. Rebuilt, rewired. Okay, what is field sense? What is call your number? Field sense improvements and sapient technology. What is it? What is it? Field sense and sapient technology. What is it? I can't play deep dive. Let's figure this out. Field sense and sapient technology. What is it? Key updates to field sense and sapient technology. Oh my gosh. Okay. The added control that field sense delivered in the gameplay was extremely positive. It's the next evolution of field. What is it? Smarter AI. Okay. Whenever they talk about how great they were, I wonder why they were just not done in the earlier version. The answer is they actually, like football is the same from year to year, and so, football the game doesn't change very much. You update the roster every year. Yeah. Gameplay emotion, game day emotion. Hit everything 2.0. Expanded mid-air catch tackle system. We can now branch to swats, catch tackles, and hit sticks in all contested catch situations, not just jumping catches. There you go. That was the feature we added this year. Great. All right. More control to defend curl routes, slants, and streaks with a variety of realistic outcomes, new animations. Great. Okay. So you can tackle people in the air. There you go. All right. There we go. So we were the team working on Madden 2024, and we're like, okay, it's going to be Madden 2023. We're going to add a couple more animations for mid-air tackles. There you go. So you make a spec sheet, and, pretty much everybody knows what's going to happen. The art team, is going to have to do hits from the side and from the front or whatever. Grabbing people's face masks, whatever. It would probably work, because it's not, it's all familiar territory, and you've done it all before. It would probably work fine. But for most large projects, they fail. Like most large projects that use Waterfall fail. Agile and TDD work better, just in general. So, what are these things? Waterfall is trying to predict the future, like you can know in advance what's going to happen. Agile is instead responding quickly to the present. So with Agile, and we'll talk about that in a second, you release constantly, and then you get feedback from your client constantly, and you react constantly to it. So the Agile approach is 200 to 300% more likely to result in project success than Waterfall. So, hey, what's up, Ada? I have a child outside of my window right now. Yeah. So if you look at this percentage, 14% success rate is not good. 14% is really, really bad to succeed at a software project. And these are not random, software projects. These are like major top 100 software projects, like the New York City time card thing, which failed, right? It didn't work. They spent, I don't know, however many millions of dollars on trying to upgrade the time card system, and it failed. It's too hard. It's an unsolvable problem. And and so challenge here means that they went significantly over budget or over time. So the waterfall method only results in project success 14% of the time. Agile does 42% of the time, which is 300% higher. And is less challenge as well. Outright failure is much, much lower. But outright failure, where you just tried and you failed, that's 30% of all top 100. These are companies like IBM, where they're like hired to like redo the national, radar system for air traffic control towers, and it fails. Like they try and they fail, and it's just rejected. But they get paid anyway because they got that spec sheet. They did the stuff, so they get paid. But we're still using the same air traffic systems that we had in the 1970s. So yeah, there's no other industry that is this bad that I'm aware of. I mean, imagine you hire an artist to paint your portrait. You go and you sit there and he paints for a couple hours. Then at the end of it, he's like, "Yeah, I don't have anything." You're like, "What? What do you mean you don't have anything?" I tried. I didn't get anything done. Sorry, but that'll be $1,000, please. Thank you. All the contract said was that I have to try. I don't have to succeed. So, $1,000, please. You hire a photographer. The photographer doesn't take any photos. Pay me $1,000. You know, try to you hire somebody to build a bridge, and 1 out of 3 times they just don't build a bridge. Okay. There's just no other industry that would put up with this level of absolute incompetence, but in computer science we do, and it's not good. And so the agile approach is an approach that is designed to try to increase the success rate of software projects. And so how does it work? Okay, so with agile development, you release often, you release quickly, you release soon, right? So if you're hired to make a new air traffic control system, then the first week that you're hired, you put together a prototype out of, I don't know, you make an MS Paint, picture of like a radar with a little line on it and some dots, and you send it over to the client. You're like, "Hey, how does this look?" And they're like, "It's a crayon painting." And they're like, I know, it's a crayon painting. Well, like, is everything in the right place? Do you like the layout of everything? And they're like, "Oh, I think it'd be better if we had the thing centered and the buttons on the side like this." And it's really important that you find that out early, right? Like if you're designing a cockpit of an airplane, and you find out at the end of millions of dollars of development that a control stick is too far off to the side for the pilot to reach it, that's a problem, right? And that's going to be a very expensive problem to fix because everything's been kind of set, the whole interface is set, all the wiring's done. You have to it would cost millions of dollars to redesign it at that point. Whereas changes that are made early on are cheaper. The sooner you can make a change, the cheaper and less effort it takes before everything else gets fixed in on it. And so you just mock up something, you send it to your client. Oh, yeah, that looks good. Or you need to make a change, and you just re-sketch it in crayon, whatever. Redo it. You have your UX UI person who focuses on the user experience. They work with them and they put together sketches and they're working back and forth. And you can do this every week. You can do it every month. You can have weekly sprints. You can have monthly sprints. And basically, in a sprint, you're focusing on one kind of thing. Like we're going to work on integrating the radar to our air traffic control system. So by the end of the week, you've got a little line that's going around here, and there's dots appearing on it, and it's connected to the whirly dish, the side of Fresno Air Terminal, right? FYI, FAT. So the whole team works together. They sprint for a week, and they build a feature. They test it. They integrate it. They send it off to the client. The client comes back and says, "I hate it. You need to make the line travel the other way." And then you go, "Oh, okay," and you just fix it. While you're working on it, everything's still fresh in your memory. Everybody knows how to fix it right now. And so you're constantly iterating. You're constantly releasing. You're constantly testing, and you always have a product that works. You're always in a state where you've got something, that you can sit down and play with, and it's working. It's not all done, obviously. Like, it takes a lot of work to do these things, but you'll slowly build one feature at a time out. So Scrum is a version of Agile that is very popular. What you do is you can establish like what it takes for your product to be done, which is wild, because most people don't ever know when they're finished, right? Now with my homework, you know, because you pass all the test cases, right? So that's very similar to what we have here. So the client might say, once you can pass all these tests, you're done. Yeah, cool. And then you work your way towards passing all those acceptance tests. And you'll have what's called a backlog, which is a list of all the things that have to be done. And things can get, even when you're going through the backlog and working on tasks, sometimes things will get added to it, right? Like you're trying to get the weather integration working, and you're you're responsible for pulling the weather data from NOAA, and they change their whole thing. And then you're going to have to throw onto the backlog, like, okay, we're going to have to pay money now to NOAA. We need to, their whole database is different now. So we're going to have to like rewrite that whole thing, and so like sometimes the amount of work you have goes up. It'll look like this sometimes. So if you look at like day 4 and 5 here, you can see the amount of work you have remaining goes up. And it happens sometimes. Like you discover that there's something you didn't know, or something changes, or something broke. You throw more work onto the backlog. And so ideally, across this month-long sprint, you see that green line going down there? That is your ideal burn down, but life never follows ideal, patterns. Instead, your programmers will be working on things, and like some days you'll accomplish a lot of tasks, some days you'll accomplish a couple, some days you won't accomplish anything at all. And what you do is you track, you start off the month with a list of tasks that are like, we're going to get weather done this month. You put all the things into the backlog that you need to get weather done, including the user interface and all this stuff. And as you work through the backlog will shrink and shrink and shrink. Ideally, it'll sometimes get bigger. And then by the end of the month, you're finished. And now it's time for another sprint. Or if that was your last thing, you're done. Okay. Now, typically, you can have weekly, daily, monthly periods of time. It's very common for Scrum Lords. So Scrum, the Scrum Master, sorry. My sister's a Scrum Lord. And basically, you'll start off, like if you're doing a week-long sprint, let's say. On Monday, everybody comes and does a stand-up, oftentimes, where everybody's standing up. Like in my in-person session, I had everybody stand up. And I'm like, and I just talked to them while they were standing. And I'm like, see, you want me to finish fast because you're all standing right now, right? And you stand up because nobody can get comfortable, right? You don't want people comfortable in sitting in chairs because then the meetings take forever. So they do stand-ups. 15-minute meeting, okay? And they do this at like hospitals now, like the doctors and the nurses and everybody that are traveling around the floor. They all meet together and they talk about what they're working on the day, the big things they need to work on, look for. Mr. So-and-so is having a lot of trouble with his kidneys. Let's spend some extra time there. And then everybody's on the same page. Everybody talks about what they're working on. I'm doing this. I had trouble with this yesterday, that kind of stuff. And then you do your sprint, a day, a month, a week, whatever. And at the end of it, you do what's called a retrospective. And at the end of the retrospective, at the end of the period, you do a retrospective. You say, hey, this went really well for me. I got this done. But I had trouble with the NOAA data. Like, I don't even know what's going on over there. They've switched out their database guy 3 times. They've gone from SQL to Oracle and back. And every time I change my thing, they change their thing. I'm just having a lot of trouble getting consistent thunderstorm data from these people. I don't know what to do. And then people will be like, well, I know somebody over there. And so you talk about it. So like whenever you have like troubles and things like that, or things blocking you, a good Scrum Lord will work on ways of pulling that obstacle out of the way. Like I need an account to register an account on the Apple development system. It's $100. I don't want to pay out of my own pocket. Could you do that for me? And Scrum Lord will take care of it. And so ideally they remove obstacles to your success. And you talk about things, or if you just have trouble doing something, like sometimes they'll just say, hey, Bob, go help out Sydney, and work on the NOAA issue together because, this sounds like kind of a nightmare. And so you can talk about what went well and what went wrong. And then you're back to it the next month, So, you just finish your month-long sprint, maybe you have a week off, to go on a vacation and do the whole thing again. And this is a fairly effective way of doing project management, basically. Okay. And so you ship to your customer. Every time you finish one of these sprints, you like push it out to your customer. Some places do 24-hour builds. Like Firefox is a nightly build you can download to always have the latest and greatest version of Firefox, but it might break. Who knows? Just depends what your release cadence is. You could have a month-long release schedule. So every month your client gets the latest and greatest version of your new air traffic control software. And then they can test it and look at it and give you feedback. I like the way this is going, but these buttons here, and when there's a thunderstorm, it should have a flashing, whatever, so they're always giving you feedback. And then the Scrum Lord will take that feedback and, for things that are good suggestions, at least, put them into the backlog. You can work through them again. Okay. So, any questions about this? The Agile is kind of the everybody does Agile. I kind of want to say it's not true, but like it's just kind of like a standard kind of procedure these days. The military is talking about how agile they are, which is a joke, considering the military is like the least agile, organization in existence. If you want to buy a laptop, it takes 9 months. I guess it's the slowest, bureaucratic nightmare. That like, oh, okay, sure, yeah, you're agile, yeah. But a lot of companies, like I've got, like my sister, like I said, is a Scrum Lord. Then I had another friend that in college I tutored her a lot in computer science. She was not a good computer science person. She was really more of a people person than a computer science person, which is probably how I ended up doing like half her homework for her, or like at least tutoring her on homework while she paid me in food. Cycle of cramming and then time off, sure. Scrum is like Agile. Scrum is a form of Agile. Scrum is a form of Agile, or you have like these burn down charts and things like that. And it's sort of like one of the ways you can do Agile. Let's put it that way. And it's named after like a rugby scrum where everybody's pushing on the ball at the same time. So everybody works hard. They work together to burn through the backlog. And then, yeah, I mean, you don't have to take time off. You go right back to it. But I mean, I'm just looking at the chart here, and it's a 21-day, cycle. So they might just start again on the next day, or yeah, I mean, realistically, I would probably. I mean, if these guys are working through weekends, apparently, because on like day 21, they're doing work. So I mean, if they're working through weekends, I'd give them a whole week off. Yeah, it seems like kind of a fun idea. 3 weeks on, 1 week off. Would that work out? No, you're probably shorting the people actually a little bit. It'd be, yeah, but if there's 30 days and it'd be 21 days on, then either 9 or 10 days off. So it'd actually probably be reasonable. You work three weeks hard and you're off the rest of the month. You work from the 1st to the 21st. I'd probably go for that, honestly. Huh. The burnout chart. You don't get weekends. I don't know. Like, I mean, there's something very tempting about like 7 days on, 7 days off, which is like what some people work, right? Because it's like, yeah, you're tired by the end of the 7 days on, but you know, you want to go to Tokyo, you can do it. You hop on a plane and spend 3 days in Tokyo, 4 days in Tokyo, and hop on a plane back and spend a day resetting. You can do it every other week if you wanted to. Like I have a friend that does that. Night shift pharmacists work 7 days on, 7 days off. So like 10-hour shifts, 12-hour shifts, something like that. Not exactly my cup of tea, but I can see the appeal of it. Okay, so let's talk about TDD. Shin, you have a question about that? You can also you can do this for your living too, right? Testing is definitely a thing you can do for a living, but this kind of project management stuff is also another thing you can do for a living. You have to have some technical skills, right? Like because you have to kind of understand what's going on, but you don't have to be great. My friend who I kind of carried through 40 and 41, like she's a Scrum Lord now. She knows the lingo, she knows how to program kind of, but she doesn't. She's a manager. So she probably gets paid more than the people she manages. Despite having less technical skills. Okay, so TDD is also sort of like standard practice. I don't want to say it's everywhere because there's a lot of old people that hate TDD, and there's definitely some downsides to it. But just for the sake of argument, let's just say it's everywhere. these days, like Microsoft and Google and all these kinds of companies. They do TDD. So what is TDD? So TDD is the notion that you write tests for your code before you code. So if you're going to be writing a function that takes, I don't know, that computes compound interest, what you do is you create the tests that say if you push in, these parameters, $1,000, 12 months, 5.2% interest, the answer should be, $1,200 or whatever it is. You solve the problems on paper, you create the test cases, and then you're going to fail them all, right? Because you haven't written the code yet. So this notion is called red, green, refactor. So when you start off, all of your test cases should fail because you haven't written the code yet, right? So if you are past, like if for whatever reason, you pass and I've got $1 million and I'm making 7.2% interest compounded daily at 3.5%. If you somehow pass that test case before you've written any code, there's probably something wrong with your test case. Like, how did I get that answer? Now, if the answer is 0 and your little stub function's returning 0, maybe. But you should start off failing every test case. This is actually a good thing. You want all of your test cases to fail to begin with. Otherwise, what are they testing? And so it's called red because when a test fails, it's red. It'll print in like red text. Then what you do is you implement your code. And as you implement your code, you could rerun the test suite. So the test suite is all the tests you have of that, in this case, a function. And as you start implementing things, then your tests will start passing. You've probably all experienced this with the homeworks that you've done in my class, right? You've got the input tester, right? And so you write a little bit of code. You do a couple like quick if statements, like, oh, if the input's too low, if the input's too high, die, and oh, look, I'm passing 2 test cases now. Cool. And so you start off, you pick off a couple low-hanging fruits, and you could pass a couple test cases, cool. And you start really working on the assignment, and you start passing more and more test cases, and you get to a point where you're passing like 9 of them, and that 10th one's like killing you, and you like don't know why it's killing you. And you finally finish it, you're done. Do you understand how cool that is? Like when I was in college, we didn't have test cases. We just would submit whatever we had. And so it was hard to tell sometimes when you're done, right? Like, have I done enough? They asked me to write a thing that'll you can insert and search and delete from a database. It's like, okay, well, I've done it. Is it fast enough? Like, I could rewrite this to be cleaner. I could rewrite it to be faster, which are not necessarily the same things. Am I done here? When am I finished? When do I stop? It's actually a really hard problem in computer science. And that's one of the best things about having test cases, is that they tell you when you're done. When you pass them all, you're done. If your test cases are comprehensive and they cover all the different possibilities, then when you pass them all, you're done. Cool. Go to Starbucks, get some coffee. Take a break. Go to the pool. Right? It's pretty encouraging to know if I'm close to success. Yeah. And so the other big benefit of that is that you start with all red, you eventually pass green. Then you pause and you refactor your code. And refactoring means you clean it up. If you have some like kind of hackish things in there, or if you have unoptimal things where you're doing like order n searches when you could be doing order 1 searches, you replace the vector with a hash map. You clean it all up. And what's really cool is that because you're passing all your test cases, when you refactor it, you should still pass your test cases, but it doesn't always happen. You rewrite your vector to be a hash map, and all of a sudden your code's failing. And you're like, what happened here? And it's because like hash maps don't allow duplicates or something like that, and vectors do. And so one of the absolute best things about TDD is that it tells you if you broke your code. So you had working code, and you were supposed to still have working code, but you broke it, and it tells you. And you're like, oh, how cool is that? I broke something. It's good that you know that. Like, this sounds like really bad. It sounds like, oh, wouldn't you rather not know that you broke the code? No. If I break code, I want to know it. Like, it's horrible. Like imagine you've got millions of lines of code and you like write to some global variable and like some other person in the 1980s is using that global variable in their function for some reason. And you just think it's unused. And so you're writing to it or because it's variable name or something. And you break their code. You wouldn't know. It's not your code, but all of a sudden the test cases over there start turning red. You submit your patch, and this is how it works at like Microsoft and companies like that. You submit your change, like, hey, I'm going to be doing this, and then they compile it in. They compile your code. It compiles, great. Then they run 100,000 tests, going through all these different tests. And if you break anything, if you break that person's code from the 1980s, red light, your submission has been rejected. And you come back in the morning because it takes a while to run these tests, right? You come back in the morning, it's like your test was your patch was rejected because you broke Bob's code from 1983, and he's dead now, so you can't talk to him. So you're gonna have to, maybe make a new global variable or something. Don't break his stuff. He's dead. But that's actually really awesome because most people don't have the courage to change old code. Because it gives you confidence. It gives you confidence in changing code because most people are absolutely deathly afraid of changing old code because you have no idea if you broke anything. Like it could be in a foreign language, and you're like, I don't know if I should change this. It looks like a bug, but who knows? Maybe it's intentional. If your tests are good though, then you can change it. And oh look, I'm still passing the test cases. Cool. It gives you confidence to change code without breaking stuff. And that's why it's really, really important to use TDD. Now, not everything can be TDD'd, but everything you can, you should write tests for. And if you have a version control system, which everybody does in professional computer science, your guys' version control system is, I don't know, saving a backup file or something. But if you're using a version control system where you're like checking in new versions on GitHub and things like that, then if you break something, you can just revert back to the previous version and be like, let's pretend we didn't see that. And so you try something new. Oh, I broke it. Undo. Go back to the previous version. No harm, no foul. Okay. Sometimes you'll break something. You don't know why. You're just like, whatever. I'll just go back to the version that works. It takes 10 milliseconds instead of 5. We'll deal with it. Okay. Now the downside is it can be slow. Like running hundreds of thousands of tests can be slow. Right? So you might not do the full test suite every time you compile your code because it'll delay everything too much. Right? Also, if you break something, it could break all the tests. like if you crash, if you made one small change that crashes your code, you're going to fail every test case. And so you're going to come in with a report of like 100,000 failed test cases. You're like, okay. Yeah. It could be hard to go through them all, Also, the tests will get bit rot. So bit rot is the notion that as time goes on, things kind of get out of date. Bits don't literally, they actually do kind of literally, metaphorically rot. Like hard drives will lose bits over time. Like the magnetic domains will. But no, bit rot refers to the fact that like over time stuff changes, right? And so like code that was written in the 1980s was written before Unicode existed. And so your system, that handles student enrollments, if it was written in the 1980s, it probably is not going to work if somebody has a Unicode character in their name. Like a E with a umlaut over it or something. I don't know. A Chinese character, a kanji. None of that's going to be handled properly by your system because your system only handles ASCII. Okay. And so, if you have old test cases, then, they're all going to be in ASCII and they're not going to be comprehensive anymore, right? They're not testing all the possible inputs anymore because you're only testing ASCII names. You're not testing Unicode names and things like that. And so somebody has to keep up with the tests, right? Like somebody has to be aware of all the different pieces of your system. And as time progresses and people move towards UTF-16, the UTF-8 and things like that, you have to keep up to date with the tests. And so even though your code itself might not change, the tests have to change and stay up to date and things like that. And oftentimes these two things have to be made together. The tests add Unicode names, and then your code has to support Unicode names. And you can't do one without the other because you might fail a test case or whatever. So you have to do both at once. And so all this just takes time, right? And so a lot of old school developers hate TDD because they hate writing test cases. They hate maintaining test cases. If the code itself changes, like if the rules for like how computing interest change, then your code changes, and then that means all of your tests that you had before are wrong now, right? Like if the rules on interest change, so compounding, daily takes the midpoint value instead of the endpoint value or something like that. Like if the rules of accounting change, all of your functions that use the old rules are now wrong, and you have to go through hundreds and hundreds of tests and update them all to the new system of accounting. And that's just not the kind of thing that like a lot of people love doing. There are people that do, like Burford might want to, but like a lot of people just like, I don't want to deal with it. Just let it run. If it breaks, it breaks. Games are hard to TDD, for example. I watched an interview with Todd Howard and Lex Friedman, where Todd Howard was talking about how they were doing some sort of testing of Starfield automated, but it wasn't like a unit or a functional test. So it's not like they're testing one function. They actually would start a new game, start a new game, and it had like, you can think of it like an automatic joystick, and it would walk the player through the first level and basically run you through the entire tutorial, trying to just basically see if the game would crash, and see if there was like some crashing bug in it. And so every night it would rerun the intro and just make sure that there were no like obvious crashing bugs. And Lex Friedman said, well, can you test to see if it's fun? And Todd Howard said something like, I don't know, if you could figure out how to tell if the game's fun, in an automatic fashion, let me know. Let's see if we can figure this out. But it was just, purely testing to see if it's crashing or not. But like things, like a lot of things, like you just can't TDD. Like, if you reduce the value of a rocket launcher from 100 damage to 10, you can't make a test like, is that a fun change? Like there's no, you just kind of have to play the game. Like, is it fun? Is it balanced? All that kind of stuff really can't be automated. You still have to have human QA people and human programmers and human game designers and things like that. Okay, so version control systems are something, like I said earlier, every software engineer needs to know how to use. Git is probably the most common these days, with GitHub unfortunately being sort of the de facto place where everybody uploads their stuff. I say unfortunately because Microsoft stole, I don't know if stealing is the right word. Microsoft used everybody's software on there that was GPL'd. And if you use GPL code, your code has to be GPL'd. They didn't. And they used it to train their AI called Copilot using, I don't know. And there's a lawsuit going on right now for it. So we'll find out if it's illegal or not. In my opinion, it's at least shady, if not illegal. So with a version control system, you can check in copies of your files and then check them back out later if you break something. So you can have version 1, version 2, version 3, to put it very mildly. And then if version 3 is terrible, you can just pretend that didn't happen, revert back to version 2, and continue on with your life. It's a lot more to it than that, especially if you use Git. Like Git is a whole lecture in and of itself. We're not going to do this today. Okay. So what we are going to do today is Rivendell. You want to come back? It's nighttime in Rivendell. Yeah, the water is moving. Interesting. Okay. So it was a misinput. Calm down. So let's talk about your lab time today. Get it right on time. Okay. So your job is going to be, for lab time, fizzbuzz_TDD. So your job is to write tests. You're going to write fizzbuzz again. You guys remember fizzbuzz, it counts from the numbers 1 to 100. And If the number is divisible by 3, you print fizz. If it's divisible by 5, you print buzz. If it's divisible both by 3 and 5, you print fizz buzz. Otherwise, you print the number. Okay. Now, this is a little bit different. We're going to be doing this in a function. Now, before you did it in like a for loop, but we're doing this in a function, so we can do functional testing. We do unit testing and stuff like that. So we can pass in a number and see the string that we get back out. And you can write a test case for it. So we have 3 test cases right here. And when you run it, if I in fact run it right now, you can type test, and then that is going to give you the we got colors now. There's no colors on this for some reason. It'll show you which tests fail and which tests pass. And right now it should all fail because I haven't written it yet, right? So I passed 1 test somehow. Which one did I pass? I don't even know. But what this means, this looks like a function. This is not a function. This is something called a macro. Okay. So this is part of the GTest suite. The GTest suite, also known as GUnit, which is written by 50 Cent, right, Raymond? Did he leave? Yeah. So the Google Test Suite, the Google Unit Testing Suite, GUnit. It's also the name of 50's rap group, GUnit. So this is not a function. This is something called a macro. And so what this is doing, it's adding to your test suite a category called FizzBuzz, and then a subcategory called good tests. And so good test is testing a valid number for FizzBuzz, like 10 or 15 or 20 or 50. Okay. The bad tests subcategory is for numbers that are outside the range. So for this function, we are not going to accept any numbers lower than 1 and no numbers higher than 100. And so we're going to have a separate like test suite or category of tests for -50, +1,000, +1,000,000, -1,000,000, that kind of stuff. And the format of a test looks like this. So we're just using expect equals for this one. There's plenty of other tests you can write. Expect near, for example, is useful for floating point numbers, things like that. So what expect equal means, it's going to run FizzBuzz, and it's expecting the output to be the string 11. It returns 11. And so we're expecting the output to be equal to be 11. And here, this is randomly generating test cases, which is kind of fun. It's generating a random multiple of 15. And yeah, in the range of 1 to 100. It's kind of clever. And if you pass in a multiple of 15, then you should get FizzBuzz as the answer. And then for 3, we should get fizz. Okay. Now for bad numbers, these are errors, erroneous inputs, -50, +1,000, that kind of stuff, and all of them should return error. Now edge cases are kind of interesting. Edge cases lie right on the boundary of good tests and bad tests. Okay. So the most common errors you get in computer science are right on the boundary of an if statement. So if your if statement says if x is greater than 1, for example, I would test 1, I would test 2, I would test 0. So wherever your if statement is, if x is less than 10, I would test 10, I would test 9, I would test 11. So wherever that edge is, I would test that particular number plus or minus 1. Because that is where people make mistakes. They're off by 1 errors all the time in code, and all the time the if statements are like the source of a lot of runtime errors. And in fact, looking at a lot of student code in 26 over the last couple of weeks, there's been a lot of off by 1 errors where people had a greater than or equal to when it should have been a greater than or vice versa. Okay. And so if I wanted to write an edge case, I could do something like this. So expect equals, and so I'm going to call FizzBuzz, passing in 1, and I'm expecting the output to be the string 1, right? So that is how you write a test case. And so what you're going to do for lab time is you're going to write 15 test cases, 5 for each. Okay? Might be a little bit overkill for bad, but whatever. You're going to write 15 test cases, 5 for each of these categories, and you're going to do FizzBuzz. You're going to actually write this function. Okay. So ideally, what's going to happen is by the end of the hour, you're going to have FizzBuzz done, and you're going to have tests for FizzBuzz. And then when you run the code, remember, you can type FizzBuzz, and nothing happens right now. But when you type test, it'll show you which test cases are failing, which test cases are passing. And ideally, all of those will show passed. Okay? So you guys got an hour to do this. Basically, write your tests first, though. Okay? We're doing TDD. So you're going to write your tests first, and then you're going to write FizzBuzz. And if you get that done, then move on to FizzBuzz 2.0, the return of FizzBuzz. So for FizzBuzz 2.0, you add the two digits together. So you do a FizzBuzz, and if the result is a number, you add the digits together and do FizzBuzz again. So if the number was 13, you'd still just output 13, because 1 plus 3 is 4, which isn't anything. But 23 would output buzz, because 23 would normally just be 23, but then you add the digits 2, 23, 2 and 3, 5. You add them together, and then you run FizzBuzz on the result. And so 5 is buzz. Okay. Should you make test cases for FizzBuzz 2.0? Yes. Right there. But I want you doing FizzBuzz 1 first. Okay. So write 15 test cases for FizzBuzz 1. Get FizzBuzz 1 done. Run test on it. Good to go. And then after you do that, if you have time, FizzBuzz 2. Okay. You have to type make to compile the code. If you try coding just with a compiler or whatever, it's going to fail. It's going to say you have to type make to compile this. Not compile, not G++. Because the GUnit suite, the GTest suite, has to be linked in like that. So you have to compile with make. Okay? If you try compiling it any other way, you're going to get a compile error. I threw that in. I'm fairly proud of that. Basically, the source code will reject your compiler unless you're compiling the code the proper way. So 15 test cases for bad. No. 5 each. 5 each. And even that is probably a little bit too much for bad. Like for bad, probably 2 is all you need. I would probably handle 4. So I'd say, but whatever, just make things simple. 5 good, 5 bad, 5 evil. Edge, sorry, not evil. And then for FizzBuzz 2, 5 good, 5 bad, 5 edge. And you got an hour. Any questions? 10 points, 10 quiz points. So make sure you get it done by 4:37. Begin.